Okay, in this video I'd like to look at displacement, distance, velocity and speed. So we'll start with displacement and distance. And I want to make sure that we're really clear about the difference between the two of these. So first of all, I'd like to define the total distance, which measures how far an object has travelled in total. And the key point I'd like to stress is that it doesn't matter which direction it has travelled in. So it could change direction, it could go back on itself, and you would just keep adding the distances together until you got the total distance travelled. And I'd like to contrast that with displacement, which measures how far is an object from its initial position. And so for the displacement, it does take into account the direction of travel. Because if something travels in one direction and then changes direction, its displacement will not be the same as the distance travelled. Let's illustrate this with an example. Suppose we have a man and he walks 5 meters in one direction, and then he stops and walks back 2 meters in the opposite direction. The total distance travelled by the man is 5 plus 2 meters, which is 7 meters. But the displacement, which measures how far is the man from his initial position, will be different because he's travelled back towards the start position. So the displacement is given by 5 minus 2, which is 3 meters, because he's 3 meters from the position that he started in. So a couple of things to note are that if something doesn't change direction, then its displacement will essentially be the same as its distance. Like here, where the man walks backwards along his original path, then the displacement will be less than the distance. Let's now take a look at velocity and speed. So velocity is defined to be the rate of change of displacement. That essentially means how fast is the displacement changing. If your displacement is changing quickly, and that means the magnitude of your velocity would be larger. Now, velocity doesn't just tell us how fast something is travelling. It also gives us information about the direction that something is travelling in. So for example, if we're travelling in one dimension just along a straight line, the velocity takes into account, is it moving to the left along the line or to the right along the line? Compare that with speed, which is simply the magnitude of the velocity, which means that speed does not take into account the direction the object is travelling in. We can easily illustrate this point with a diagram. Suppose we have a bike with a velocity of 30 meters per second travelling to the right. If the bike was to turn around and travel in the opposite direction, then its velocity would be minus 30 meters per second. Compare that with the speed of the same bike. If it's travelling to the right, it would have a speed of 30 meters per second. But if it travels in the opposite direction, it would still have a speed of 30 meters per second. So the key thing to take away is that velocity includes information about direction, but speed does not. It's simply the magnitude of velocity, which tells us how fast it's going, but not where. Before we finish, I'd just like to talk about acceleration. So acceleration is defined to be the rate of change of velocity. That just means how fast is the velocity changing. And since velocity takes into account direction, so does acceleration. And the units we use for acceleration, which we mentioned earlier, are meters per second squared. The reason those units come about is that if you think of the units of velocity as meters per second, and we want to know how fast is that changing, that is meters per second. And as we apply the per second part twice, we get meters per second squared.